Hello students, so we have solved question number 32, first part, that is there are two questions in that, or question is there. So second one we'll solve today. So question 32, the or part. So y equal to a e raised to minus kx cos px plus 4, then we have to prove that d square y by dx square plus 2k dy by dx plus p square plus k square y is equal to 0. Okay, so y is a e raised to minus kx cos px plus 4. Okay, taking the derivative dy by dx, we'll get a minus k e raised to minus kx cos px plus 4. This is your u, this is your v, so uv rule you have to use. So u dash I have written. Now I'll write the v dash. This minus sine px plus 4 into p. Okay, so this is minus a k e raised to minus kx cos px plus 4, then minus pa e raised to minus kx sine px plus 4. This is your y dash. Okay, now you can substitute here. Our y is a e raised to minus kx cos px plus 4. So here you can substitute your y. So taking k outside, get minus k y minus pa e raised to minus kx sine px plus 4. Okay, now we'll double derivative it, d square y by dx square, okay, which is y double dash. So ky becomes minus ky dash minus, I'll write pa outside, and then derivating this term, minus k e raised to minus kx sine px plus 4 plus e raised to minus kx cos px plus 4 into p. Okay, so y double dash equal to ky dash plus pa k e raised to minus kx sine px plus 4. Then again here also pa I'm taking inside, so it will be p square a e raised to minus kx cos px plus 4. Okay, now again substitution, p square and this term is our y, right? So I can write here p square y. Now this term we have to write. Now this is sine px plus 4. Okay, y dash, in y dash we have e raised to minus sine px plus 4. Okay, a is also there and p is also there, only thing is k is not there. Okay, so if I take these two terms here, it will be y dash plus ky equal to minus pa e raised to minus kx sine px plus 4. Okay, and we want k also, so I am multiplying k here and also here to this term. Okay, so I'll write this term as this, and minus sign we have to put here, minus k y dash plus k y. Okay, this is y double dash. So taking all the terms this side, you'll get plus ky dash plus p square y plus ky dash plus k square y equal to 0. Okay, so ky dash becomes 2ky dash. So y double dash I can write d square y by dx square plus 2k dy by dx plus y I can take common, so this will be p square plus k square y equal to 0. Okay, this is the required equation. Next question, question 33. Okay, if the function is defined by function is given, I'll write the function. Okay, f of x equal to 1 plus sin x upon a cos square x minus pi x by 2, then 3 sin 2x plus b pi by 2 to 0 and e raised to 5x minus e raised to 3x upon 2x 0 less than x less than or equal to pi, and the function is continuous on the interval minus pi to pi, closed interval minus pi to pi. Okay, then you have to find the values of a and b. Now here when you consider this function, then your left hand limit becomes this and right hand limit becomes this. Okay, for left hand limit you can take this. For this function left hand limit is this and right hand limit is this. For this function left hand limit is this. Okay, so let's write. Now we can say that if function is given continuous on interval minus pi to pi, right? So limit x tending to, this is our left hand limit, for this it is right hand limit, so minus pi by 2 to plus f of x is equal to limit x tending to minus pi by 2 to minus f of x, that is first we have to find this and then we have to equate this. Okay, so limit, these are continuous, x tending to pi by 2 minus pi by 2 plus f of x is 1 plus sin x upon a cos square x. Okay, so this is, we can write it as limit as minus pi by 2 plus 1 plus sin x upon a cos square x, we can write it as 1 minus sin square x. 1 minus sin square x, we can write it as a square minus b square, so it becomes a minus b, a plus b. Okay, so this gets cancelled, then putting the value of 1 minus sine minus pi by 2, so sine of minus pi by 2 is minus sine pi by 2, so this becomes plus, so sine of pi by 2 is 1, so this is 1 upon 2a. Okay, then this is our right hand limit, then left hand limit as x tending to minus pi by 2 minus, you have to take this 3 sine 2x plus b. Okay, substituting the value 3 sine 2 into minus pi by 2 plus b. Sine pi is 0, so this is b. Okay, so this is our 1 upon 2a equal to b we'll get. Then second, we have to take right hand limit this one 0 0. Okay, limit as extending to 0 plus, okay, 3 sine 2x plus b. Sine 0 is 0, so this will be b. And left hand limit as extending to 0 minus e raised to 5x minus e raised to 3x upon x, so you can write it as 0 minus e raised to 5x minus 1 minus e raised to 3x minus 1. Okay, we are adding and subtracting 1, so using the limit formulas, this becomes log e raised to 5 and log e raised to 3, or you can write it as 5 minus 3, so this is 2. Okay, so our b value, this is first one, second one, third and fourth. By equating third and fourth, because they are continuous, so b is equal to 2, and by equating 1 and 2, okay, 1 upon 2a equal to b is 2, so 1 upon a is 2 into 2 4, so a is 1 by 4. Okay, these are the values. Let's solve the next question, question 34. Okay, you have to find the inverse of a matrix A and solve the system of equations. So I'll write the matrix. Okay, and system of equations given: x plus 2y plus 5y 5z equal to 10, x minus y minus z equal to minus 2, and 2x plus 3y minus z equal to minus 11. Okay, so from this we know that this is our A matrix. B matrix is this 10, minus 2 and minus 11. Okay, first you have to check for A inverse exists or not. So first you find out the determinant of A. Okay, so 1 plus 3 minus 2 15 plus 2 minus 2 into minus 1 minus plus 5 4 17 6, so 27, which is not equal to 0. So this implies A inverse exists. Okay, now we have to solve. We have to first find out the inverse. So to find inverse, first you find out the cofactor matrix. Okay, cofactor matrix of A. It's plus, minus, plus, okay. So 1, this is 4. For this it is minus 17. For this it is 3. Okay, 2. 1 minus 1 plus 2. So 1. 3 plus 2, 5. Minus 1, minus 10, minus 11. 3 minus 4, so minus 1. Minus 1, minus 5, minus 6. Yeah, minus 1, minus 2, minus 3. Okay, so this is our cofactor matrix. Now adjoint of A is transpose of cofactor matrix. So transpose okay, this is our adjoint of A. So A inverse is 1 upon determinant of A into adjoint of A. Okay, so this is 27th and adjoint of A is this. Okay, so we have to find, this is our equation Ax equal to B, right? So we have to find x. So this is A inverse B. So we have to multiply A inverse to B. B matrix is 10, minus 2, minus 11. So multiplying you will get 4 into 10, 40, 34, minus 33, minus 10, 22, 66, 50, plus 33. Okay, so this is 67 minus 40, so 27 minus 27. Then this is 11, 66 and plus 11, right? So this is 55. This is 12. 54 minus 54. Then 83 minus 2, so 81. Okay, dividing by 27, we'll get here minus 1, minus 2 and 3. So XYZ are minus 1, minus 2 and 3. Okay.